Imagine you need to make a ring of fire for your game, but you kind of don't know how, to be honest. Maybe something like this is what you're looking for. Now, it doesn't have any fire, but it is a ring. And you can add the fire a lot easier than making the ring. Well, that's what the math library is for. We probably need to use sine and cosine to find the x and z axis so we can offset these perfectly. Notice how this makes a perfect circle. Or maybe let's say you have a player who you want their health to be from 0 to 100, but you don't want it to ever go below 0 and never want it to go above 100. Well, the math library is very useful for that. So let's actually make a new script in service. And here's a script for the floating circle if you guys want to use it. I'm going to comment this out though. Actually, you know what? Let's go over this. I'm going to actually center this or a couple lines down here, and I'm going to go explain this. So we know in a perfect circle, we have a radius. So our radius here is going to be 10. And our amount of circles or parts I want to make, I'm going to use 12, and I'm going to for loop it. Now the angle between each circle is going to be 2 times math.pi. The reason why this is the angle is because if you don't know a unit circle, or you haven't taken any calculus courses, or you're not as very good at math. I'm assuming most of you are not in high math level courses, probably not even in high school, honestly, because you're watching a Roblox scripting guide. 2 times math.pi is 3.14, just makes a perfect circle, or a circular. And I'm going to divide this by the amount, and I'm going to multiply that by I. So which amount, like this is the 5th part, 6th part, 7th part, and so on. I have a tuple right here for my x-axis and my z-axis. In order to find the x-axis on a graph, we know math.cosine of our angle times our radius is going to give us our x-axis for that part. And then math.sine, the sine of that angle times radius is going to be our z-axis. This is pretty elementary calculus. So if you are not familiar with this, that's fine. I don't expect you to be. This is just explaining how this works. And now we notice that I have the position of each part. This is actually how we make them offsetted perfectly from each other. Is I took the position of some part, so I have a center part that I want them to be centered around. I've added that to the position. I added a vector 3, so an x, y, z axis, of that x that we made up here. I added a y offset, so it's going to go up by 5 studs. You can leave this as 0. And then I manipulated the z axis. I added that onto the vector, which is this z axis we made right here. And I also have the color as a rainbow. I'm using the I part divided by the amount. Next up, or actually, yeah, let's get rid of all these comments. Yeah, let's just center this down. So if you want that code, you can copy it if you like. If what I said made sense, you can probably make it by yourself. Probably. But let's actually go over some of the math library functions. So to access the math library, we're simply going to say math dot, and then we have all of these events that we can use, and there's a bunch of them. You can really understand. I'm not going to go over all of these, but a lot of these are pretty useful, and you can understand a lot of these just by reading them, really. Also, if you have a basic calculus knowledge, like Calc 1, or probably 2 actually, then you would know what most of these do. But I'm going to show you guys how to use them. So we used math.random as its own separate video, so we're not going to go over that. However, we have really good ones like clamp, math.floor, and math.ceil. Now, these are the ones you probably should know. So let's go over each one. So math.clamp, we can print out math.clamp. This is going to return a number, obviously. It's going to clamp a number between a minimum, a maximum, and the number itself. So we can put in a number. So we can say local number is equal to 7.8, right? And I want to clamp this. I want to get the clamp of this number. So I'm going to put in our number, pass it in. And then this is going to take in our minimum. So I want this to be clamped between 7. And I want the max to be 10. So I'm actually going to say 5. And we can just look in the output and see what this prints out when we clamp between them. We get 7.8. And now let's make this a whole number actually instead of 7.8. Or actually, let's test this out with if it was 3. What if the number got below the minimum? What would happen? It returns 5. Very nice. And then now what if the number was above 10, our upper bound, our maximum? It gave us back 10. So the number is always going to be between 5 and 10. So whatever number we pass in here is going to return us either the lowest value or the max value, or if the value falls in the range of 5 to 10, it's going to return the number itself. So if I put in 6, it's going to return 6. However, if this number somehow became 3 or 20, then it's going to respectively be 5 and then 10. So then what about, let's actually make this like a decimal, like 7.6, maybe 6.7. How about that? That's a great number. So print math. Now let's use the floor function. So it's going to return the largest integer smaller than or equal to x. So the way I like to see it is literally look up and down in real life, and you have a floor and a ceiling, I presume. The floor is going to be the highest number this can be up to, and the ceiling, or sorry, the floor is going to be the lowest number this can be up to while still being in this range, and the ceiling function is going to give us the highest number this can be. So I'll show you right now what I mean. So this is going to return the largest integer smaller than or equal to our x, which is our number that we're going to pass in. So I'm going to pass in number, and to be honest, like reading these sometimes might confuse you. If you really just print them out and look in the output, they're going to be making a lot more sense. So look at that. It gave us 6. So and remember what an integer is. It's a whole number, not a decimal. And we pass in a decimal, so it's going to give me the smallest number within the range of 6.7. So the smallest whole number is going to be 6. So it's going to floor it all the way down to 6. It won't be above 6, and it will not be below 6. It's going to floor it down all the way to 6. You can think of it as this number right here before the decimal is our lowest, like our floor. And then in the number, our second number here after the decimal is going to be like is every number in between up until this number. That's a weird explanation, I'm not gonna lie. But from that print, you should be able to understand math.floor is gonna just floor this down to the smallest integer it could be. And now let me actually hold on. Let me go into right here the script, and let me disable the script because I keep seeing a bunch of stuff in the output. That's from the last video. So now we can just print out math.ceiling of our number. And what do you think this is going to return? If the floor returned the smallest integer greater than or equal to x, and it gave us 6, then the ceiling is probably going to return us the smallest integer larger than or equal to x. Which is kind of weird explanation. Larger than or equal to. Anyways. And it rose all the way up to 7. See that? Now let's say we had this as just 6. What would happen here? And a matter of fact, we can see this with all of these. So in the floor, it floored down to 6, and then the ceiling, the highest number is 6. Remember, there's a bunch of different numbers from the ceiling and the floor that it could be up to. And it's gonna, the floor would bring it down to the lowest number it could be, and the ceiling would bring it to the highest number it could be. So if this is like 6.3, for example, remember, these are supposed to return integers. So the ceiling, it will just take the decimal and make it the highest integer, one integer to the right. So this would become 7. 6.1 would become 7. 6.2, 7. If we use the ceiling function on it. 6.4, ceiling, or 7, sorry. 6.8, it would give us 7, and so forth. Now 6.9, it would become 6. It would floor it down to 6. Contrary to both of these, we have print.math.round. Now, if you've taken like elementary math, you would know what rounding does. It's gonna between 0.5, so we can say number. It's gonna give us either a floor or a ceiling value depending on whether or not the decimal is greater than or equal to 5. So if this is 6.5, it's gonna give us 7 if we round it up right here, and if it was like 6.3, it would give us 6. So it's just rounding the number. That's what math.round does. It just rounds the number. It's pretty easy to understand. We also have a bunch more in this library, like math.huge. This one is going to give us, look at that value, 2 to the 1,000. This is going to give us like some huge number. This is a whole different use case. I don't imagine much of you are going to use that, but yeah. We also have math.absolute value. So we can take the absolute value of anything. I'm not going to print this out because it's going to take a minute, but this will give us negative 10 because the absolute value. I'm actually going to print it out, yeah. The absolute... Oh, it has to be a negative. That's right. Absolute value of positives is positive. Completely forgot. The absolute value of negative 10 is going to be 10. See that? The absolute value will turn the negative into a positive. And then we can also print out... Let me actually just do this right here. We can also print out math dot like cosine, sine. There's max. So this is going to return the maximum value among the numbers that is passed on to here. You can play around with a lot of these. These are really useful for whatever you need. So if you ever think, man, I need a number between this, look at these math library and see which function is going to be the best for you. Is it clamp? Is it going to be math.max? What's it going to be? And then there's also exponential. This is just e to the x. I'm sure not many of you know that. There's degrees. This will convert any number into a degree. So I can say this And I can actually use this more practically. I can say, well, I don't want to do that. But this will just become sine of 45 degrees. If you know anything about math, you know, like, that's what radians are. Sine. Yeah. Yeah. Our unit circle. Yeah. And I'm going to just do that. And then we can print out math dot. There's also math dot. This one right here, this is sine. So it returns -1 if x is less than 0, 0 if x equals 0, or 1 if x is greater than 0. This is because, don't quote me on this. I'm not a math professor. I just I just take a lot of math courses. I'm pretty sure because math.sine, like in geometry, trigonometry, sine is never less than -1 or greater than negative. It's never below -1 or like to the leftmost of -1 and never above 1. So it's anywhere, but it's literally clamped between -1 and 1. So that's what this is saying. Basically, it's gonna anywhere from -1 to 1 depending on the value. We also have math.pi, like I showed before. This is just the value of pi, 3.14. This lerp. This is a great math function. This deserves a whole new video, honestly. So bear with. This is a pretty advanced one too. So this deserves a whole new video. This will drag on the video for a while. We have log. This gives us a log and a base number. If you know anything about log, you know this is pretty easy. It just gives us the log, the value of that, our number and our base. We have power. This is takes in two functions or two parameters. So if you take a C++ course, you know that views IOStream, I think it was. No, that C math library, you would take 2 and then 5. And it's just going to return 2 to the power of 5 right here. So our x is our number, and then y is our exponential, which is pretty cool. We have math dot, and I'm just yapping like through all of these. I'm not even showing you like cases. Now, this right here, so a bunch of these you're not really going to use, honestly. Most of you, I'm probably going to expect you guys to use AI to give you like math calculations, which is completely fine. If you're not in courses that require like, you're not going to use a lot of math. If you're not going to, you don't know them. I get it. Now this deserves its own video because this is so sick. Noise. I will say, though, a hint. I've seen someone use math.noise to use like it would be the volume of their mic to make parts go to the size of their volume of their mic. So if they talk loud, a part would get louder or a part would get bigger, which is pretty sick. But yeah, I mean, if you want to like, I mean, that's really about it for the math library. But one way I use the math library is like clamp. I clamp my player's health from, I give it like, I pass in like player health. And hey, I'm clamping in from 0 to 100. I don't want it to go below 0. If it's 0, he died. I don't want him to go above 100. His max is 100. If it's 100, give me back 100. If it's below 0, give me back 0. He's dead. You know? It's a great way to use math.clamp. If you want to like round up like random damaging, I like to use ceiling. So depending like on, if I have a shotgun, I'm using ceiling to say like, give me the highest integer greater than the like damage. And the reason why is that because my damage is calculated based on like distance and it's going to give me a decimal and all that. And I'm like, I don't want decimal numbers to take damage. That's weird, you know, just give me the ceiling or the floor or round it up. Rounding up is probably actually better. But you can use either or, you know, if you want your shotgun to be a little bit stronger, use ceiling. If you want it to be a little bit weaker, you can use floor. Or you can make it balanced, use round. That's a pretty basic use case in the math library. Or the floor, ceiling, round. But yeah, there's not really much else to say for the math library. You can mess around with all of these, find out what each of them do. A lot of them are really useful. This is really nice to know because we're going to be using these later. So it's just nice to have these in your brain to know exactly what these do and how to really use them. So yeah, we want to call the math library. We want to use some functions. We can use math dot, and we can look at all these functions. I will say though, the most valuable one is probably like clamp, floor, random probably actually. Yeah, probably random. And yeah, that's really about it. I'll see you guys in the next one. Bye-bye.